Hi, good morning, and thank you for joining me in my shop here on May 16th. A beautiful sunny day, and I really don't want to be in here too long, but let me set something straight first of all. I showed a picture of this radio and its cabinet, and I mentioned in the photograph shows a cabinet slightly different from mine. No, it doesn't. It doesn't. Mine is exactly the same. Cabinet has the same angular shape here. I guess I looked at this cabinet like this a couple times and kind of thought these grooves were cut open all the way across, but no, it's exactly the same as the photograph that I showed. And yeah, this is very heavy. It's got the speaker and the plate in it, but wow, this is really quite heavy cabinet. Quite a heavy cabinet. Maybe it's been built extra rugged because of its purpose. I think it was going to be in some rugged environments. So, okay, so the question with this radio is, what's that resistor doing there? I operated the radio yesterday. This resistor got plenty hot with low supply voltage, and it appears to me it is nothing more than a resistor sitting on the high voltage supply connected to B minus, or the chassis in this case, just bleeding off power. For what reason? I don't know. It's really quite a mystery why that is in there. So we're going to investigate that a little bit, and probably going to remove it in the end. That's what's in my head right now. So we're going to investigate, what is that resistor? Did I say something about looking at the schematic? I don't have a schematic. I can't find a schematic for this radio. So I just finished another search. There's just nothing anywhere except those photographs I found, which I showed on the last video. So the real question is what to do about this resistor, and I think the first thing is examine it much more carefully, how it's in the circuit, and make sure I'm not overlooking something or misunderstanding where the wires are going or something like that. For crying out loud, I can see clearly, just standing here, this resistor is clearly connected to this chassis terminal. I mean, there can't be any question about that. I might as well settle this right now. The other end can only be going to this terminal point. Certainly looks like somebody soldered here, not me. And this resistor lead is on the very top of the terminal here. It's not in with all the rest of the leads that are in there. So it's as if it's been added in later, but I don't know. So somebody made a mistake. Somebody, if I don't have a schematic, probably the other guy didn't have a schematic either. And we can't be sure about the speaker yet either. It could be that this was changed from a field coil radio to a permanent magnet speaker, rather. The obvious thing is we'll just cut it out and see what happens. It can't be anything other than what it looks like. It's right off the B plus, right to the chassis. And what did I measure it at? I measured it at, it was a fairly high resistance, wasn't it? Wasn't it quite high? Let's measure it again. Not that it's going to have any bearing on things, but maybe the more time I spend poking around here, the more time I have to think up something useful. Anyway, let's see what you say here. It's going to charge up the capacitor there. Well, it looks like 25,000 ohms. That's really big. Is that, yeah, 60K is what I'm set on. Yeah, 25,000 ohms. Why would that be there? What is a 25,000 ohm high wattage resistor doing in this radio anyway? If it was a field coil, No. I answered my own question before I asked it. Could it be the case that the guy thought this was somehow imitating the field coil? That he felt the field coil current had to be kept flowing? There is the odd radio where the field coil current is actually a separate current supply, specifically for the field coil of the speaker. Most radios, the field coil is part of the power supply filtering system, but not always. But in this one, if it were in there, it would be that. It would be that. And then we do have this resistor up on top. Let's look at it again, which appears to me to be added in. A couple of reasons. One is you put this resistor up here so it won't heat things up underneath, and you've located it right next to it too. It doesn't quite make sense. When there's other alternatives, it could be brought further forward. I mean, it could be anywhere in here. It doesn't have to be right up against this tube. It's a clever thing, whoever did it. It's a clever move. Assuming that resistor is an add-in. Now that would be the replacement resistor for the field coil. That's right, and that's why these wires are coming up here, because they were coming up to the field coil of the speaker. And now instead of the field coil, they're going through this resistor. That makes good sense. That story works. It's actually quite close to developing a short circuit here. If you just twist that a little bit too far. Trying to spot the screw that's holding it. I'm just going to tighten it up a little bit. Okay, so if this is a field coil radio, what is this capacitor or this resistor doing in here? How does that play into things? Why? Well, I guess I can just cut it and play the radio, and we'll see what happens. I really don't know any other way to go with this at all. I mean, it's a large resistor, so it's not pulling huge current, yet it's getting very hot. So we're just going to nip it here. This is going to ruin this resistor because it's got no lead on it anymore. Out you come. Might as well cut it right off because it's finished. $25,000 ohms. Okay, now the idea is run the radio, see what happens, stand back, and we'll see in a bit. Okay, let's try the radio out. Now I'm going to do this with, of course, restricted power, and I better have my thermal tool. Of course, this resistor is not going to get hot, is it? But just in case something else decides to get hot, let's just have this at the ready, so that way I don't panic. Maybe the same thing with this voltmeter. Yeah, I think I really should be set up to read the B+ voltage. Now, could it just go wild without that resistor there? I think no. I actually think the resistor did not draw enough current to really throw the power supply off or pull down the voltage of the power supply too much. Don't know though. So we'll put the positive lead for the voltmeter right on this terminal here. Maybe here, same thing. These two terminals are tied with a wire. B+ terminals. Okay, put that there. And careful, careful. Put this here, like so. And we'll set this to read DC voltage. Okay. we in the clear? Is everything ready to go? I think so. I have to keep telling myself what I expect to happen. They have nothing to do with what's going to happen. So I kind of have to be prepared for the worst here. What could happen? Remove the resistor, power supply voltage goes up 6,000 volts. Yeah, I don't think that's going to happen. I'll turn this down, and we're going to have both lights in. Okay, here we go. Did I? Here we go. There we go. Whew, she is going sky high. Now it may go way up. Luckily I put 450 volt capacitors in it. It'll come back down now. It's just like magic. It's listening to me. Turn this up. We hear nothing. Nothing. How come nothing? So we're supplying the radio with all of 72 volts. Here it comes. That's a piece of crap. Sounds like crap. Oh my gosh, what is going on here? Oh man, no schematic. It sounds like an open volume control is what it sounds like. So 230, that doesn't sound unreasonable. Yeah, anything getting hot. Somehow I just don't think so. I don't think so. What about that resistor up on top? Just a little warm. Not even getting hot. So we're only at 67 volts now. Holy smokes, that's really low. How come so low? What's going on here? This is pulling a lot of current. Oh, I know why it's low. I got this set down. It's just going to get louder, hummier. Oh my gosh. Well, you sit there and stare at it. Is the radio working despite the hum? Oh, the hum's coming right through on the volume. What are you up to? Since nothing seems to be overheating, let's just leave it running here. I'm trying to see if the tubes are oh, this came on. I saw a flash of light. What is that, lightning? Can't be lightning. I guess realistically, oh, I can't see any of these tubes operating because of just too much light in here. But you would think if the tube's not operating, you're not going to hear anything. Let's touch the antenna. Not quite the response you want. Let's touch the audio input here. Now I can do this safely. Radio's plugged into an isolation transformer. No grounds are on it, and I'm insulated from Earth anyway, so that's why I'm able to do this. Okay, well, we know the audio circuits are working. Why not the radio? Is it working and I don't realize it yet? I have no real... I put a real antenna on this. A real McCoy antenna. Better way would be to... ooh, I better be careful here. I got some high voltage floating around on these leads. Careful, careful. What are you going to do with it? This is not a very good arrangement either. Okay, operating with 70 volts on the radio, and we got that kind of B plus on it. Whew. You just assume you double it, like raise this up to 120. This is going to go up to 300, 350. Right, I was going to do some signal tracing. Okay, now I am going to attach a ground. That's this one here. Well, that's a little better. So what's that telling me? It's telling me, what is it telling me? This radio is, how does it treat the chassis? You know, I really haven't looked at it so closely yet. I see lots of ground wires soldered right direct. I said lots, I see one. Do I see more? Oh yeah, of course, and that resistor was right onto the chassis, and all these parts are right onto the chassis. So the chassis is humming, I don't know, plugging it into an isolation transformer encourage a hum like that? So this is set for audio. This is my signal tracer over here. So let's listen to the input to the volume control. I could find it right here. Get my hand on the volume control here. Just a hum, I don't hear anything. Wait a minute, that's the output of the volume control, that's not the input. Okay, the input to the volume control. Ooh, what was that? It's a big long wire going all the way, it looks like, to this terminal point here. That's what you hear. Turn this down. We're just hearing the sound from the signal tracer. Antenna. That was really that's really dead. Did I get that right? Maybe I didn't get that right. Let's go again. So that's the wire. No, it clearly comes to the terminal I was testing, and you know what? From there, a wire runs right to here. So that's definitely the audio input to the volume control. Ain't nothing there. I think it's probably tube testing time at this point. I think that's probably what we got to do. Tube testing time. Okay, yeah, we will test the tubes in here and find out if some are bad. I have a pretty good collection of these 7 tubes. They're not 7-volt tubes, they're Lochtel tubes. I guess one of the possible things here is the tubes are mixed up and they're not in the right positions. So this first tube here is a 7A7. It's located right between the two IF transformers. It almost certainly, I shouldn't have called it the first tube. First tube I'm looking at. This is a 7A7, and it says it's a remote cutoff pentode used as a RF or IF amplifier in radio receivers. So that would sound correct. 7A7 primarily for renewal purposes. I don't quite understand what they mean by renewal purposes. Okay, so first tube we're going to test 7A7. The output tube and the detector tube are probably okay because I've touched the audio input here and we heard sound coming out of the speaker, so we can assume that's enough for now, that these two tubes they're doing something anyway. Quickly, Batman to the tube tester. I have to plug it in and get it. Actually, I just have to turn on the power, really, that would be better. There we go. So I'll let you watch this first one in case you haven't seen somebody test a tube before. Many tube testers. This is just one, and this is a better one. This is a dynamic tube tester. Let me just drop some of the lighting here. It might look a little better for you. Okay, 7A7. Now, having dropped the lighting, I myself can't see anymore. 7. Here it's over here. 7A7. There it is. Okay. Put a bit more light like that. 7A7, 6.3. Okay, that's the filament voltage. Signal level 2. This is a dynamic tester, so it actually puts a signal on the tube. 29L. 29 low. Okay. And the numbers are 73421, 73421, and 5160. 5160. 44 meter sensitivity. C for the plate. Okay, now Loctol. There's my Loctol socket here. This is my kit here. You can see the heater coming on. So that's a good sign. Give it a moment. First test will be for shorts, in case some of the elements inside the tube have moved and they're touching now. You know, that could cause a hummy radio. So let's look and see what we got here. So we're watching for the meter to jump way up. And it's not jumping up at all. Ready to do the test. This tube should be above 1350. 1350 would be about here. Or it's time for a new tube. I can see it's well above. This guy's not causing a problem. Okay, I'll get the next tube set up and we'll see the result. So just before I put the tube in the tester, I notice in here it's listed as an octode. An octode. That's an 8-element tube. 7A8. Let's just look inside this thing. Here we are. Wow, there's quite a few grids in that baby. Holy smokes! Wow, that's got a lot. That's got more grids in it. More grids than I can't come up with a joke on that. So we're all set to go here. Oh, that's not the right spot. I don't see any heater. Oh yeah, heater's on. Okay. There we go. Any shorts in here. So the switch is selecting different combinations of tube elements that might be shorted. Oh, there's a lot of elements in there. Certainly a lot more than 5 combinations, but okay, and this tube on the test, 975. Whole tube, it says 975. So right just above my finger, way above my finger. So it's 2 tubes that have tested really well, which starts to suggest not a lot of mileage on this radio. You know, really from here, it's the detector tube. 7C6. Let's check it in the book, just to be sure. 7C6. Twin diode, high mu triode. So that sounds like a detector tube. It's got the triode in it. Yeah. Okay. Just on the off chance that somebody, I have gotten a radio where somebody just filled it with tubes, and the tubes in the radio had nothing to do with the radio itself. Oh yeah, we gotta set the numbers here. 7C6. You never know what people are doing. 7C6. 2 tests. 6.3, signal level 2. 9L, just like it's set. 73510. 73510. 0K60. 0K60. 44 F. Don't want to get this wrong. K1 and K2. So we're doing the diodes first? I don't know, because the next test, no, next test is a diode. K1 and K2. So K1, K2 is a switch here for switching between cathodes. I don't know why. Well, you know what it might be? It could be there's two pins. Oh, could be two pins connected to the cathode, and you're just flipping between the pins here. That's probably what's going on. Okay, we're ready. When I do the diodes, I flip the plate switch here, the P1, P2 switch. You switch plates, you switch diodes, test each one individually. So, this tube to be considered good, it's got to be above, only where my finger is here. Doesn't have to go up very high. I didn't do the short test. We got a dead tube. Is this the deal? Hello. The heater's on. The heater is on in there. In case you're wondering what happened over here, I just triggered an automatic light in the next room. Oh, 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 oh. Oh, I didn't have it plugged in tight. Shorts again. Did not have it plugged in tight. How do you like that, eh? Wow, it's pretty easy to throw away a good tube with a tube tester. If you gotta make any little mistake and you think the tube is bad. This, oh, diodes. Okay, leave it out. We'll switch to the diodes. 70013, 70013, P060, P060, 48, A. P1, P2. Plate 1, plate 2. How about it, diodes? So for the diode test, instead of flipping this switch, I flip this one here that says rectifiers and diodes. And instead of reading a value and checking against it, there's a spot. Diodes have to come above my finger here, and rectifiers have to come above my finger here. So our diode test is here. So this is what we're going to look for. After I do the shorts test, diodes, let's see, it's above that mark, and the other diode well above it too. So this tube is not causing a problem. Now, I mean, we're really running out of tubes here. Since I'm doing it, I might as well check the output tube. 7C5, and it's a tall tube. That's a giveaway that it's either a rectifier or an output tube. And a taller bottle, more to handle the more heat that's going to take place in the tube. 7C5, let's just carry on the way we've been doing this. 7C5. Beam power tube. That's all we need to read. No surprise there. 7C5. Signal level 1. That's surprising. Usually you're pumping a high signal into an output tube. 31H. 31 high. Okay. 73400. 73400. 5160. 5160. 36. Is that what that says? 35. D. 7C5. 7C5. 1, 7, 3, 7. I'm just double checking. Yeah, we're good. There we go. Oh, it doesn't go in very good. It's supposed to snap in. It doesn't snap in. Okay, give it a moment to warm up. Any shorts in the output tube? None are found. Okay, for this tube, 7C5, 1220. So 1220 is, well, it's 1500 halfway up. 1220 is right in the middle of there. Whoa, she's a beauty. So all the tubes are beauties in here. Now, when I look over and I see all these logical tubes, and then I see this thing. There are logical rectifiers, but you know, oh my gosh, that's a 4-pinner. That's right, I remember seeing that. This is a number 80. It is. This has a number 80 in it. Whew. It's a valuable tube. It's worth more than the radio. Huh. Is it worth testing this? I guess it is. I guess we might as well. I mean, if I don't, then I can't say I did. Number 80. Wow, now that's a tube I don't test very often in here. Number 80. Number 80. Filament voltage is 5. It's a rectifier. Whoops. Most rectifiers are 5. This doesn't matter. This doesn't matter. 73P00. 73P00. 6,000. 25. E. P1 and P2. It's a two-part tube. There's two sections in it. It's a really good looking tube. Like the pins look just like it came out of a package just now. Okay, just double check a couple things here before I plug in this very valuable tube and blow it out. 80. So 5 volts. Yes. That's about the most important thing. 73P00. 73P00. 6,000. 6,000. Okay, we're good. So fat pins going in right up in here, I think. Bring this forward a little bit. There we go. You can see it heat up right away. I can see it. You can see it too. Shorts. Oh! Okay, so this is possible that this is normal. Short in 1. If that's normal, it will say it here. 80, it does. So it has note F here, and I know note F means short on number 1 short test. So that's just totally normal. So everything's normal. So to test this tube, we're going to push the rectifiers and diodes. This is a rectifier, so now it comes up to here, at least up to here, and to P1, P2. So here we go. It's right up there. And the P1, P2. Nothing wrong with this tube either. It's a beauty. Gee, what's a number 80 worth these days? A good number 80. Maybe I'm going to check on that. I can't tell the big ones from the small ones here. There we go. Well, all the tubes tested. Good. No, that's not good. I wanted one of them to be bad. That would pay off. What's a number 80 worth these days? So I'm not promoting this company, the Tube Store. They're located in Hamilton, Ontario, not too far from here. And when I buy tubes, I usually buy them from these guys, just because they're Canadian here. And the tube shows up in my mailbox in just a few days. Number 80. What do you say about that? Number 80. So here we are. Let's see. What? $1,000. $1,000 for a tube? The Carry SLI 80 integrated ultimate package. What is it? Here's one here. Though this is cheap. $500. Here's another one. What's this? Integrated amplifier package. Wait a minute. This is not what I think it is. 4 results for number 80. I don't know what I got here. This looks like number tube. $25 a piece. That sounds more like it. Out of stock is the main thing. So this price doesn't mean anything if they're out of stock. Let's just try another search here. So we'll go vacuum tube number 80 for sale. Right, up to 90% off. 90% off. What are they talking about here? Quickly, I had to get a deal there. 90% off. Yikes, what's all this stuff? I don't know. Okay, I don't know where I went. Forget that. Radio vacuum tube. Here we are. Antique radio supply. My mouse is stuck at the moment here. Here we go. So this is an American outfit that sells tubes. Just $30. Okay, so they're not quite as valuable as I thought. I thought they were way beyond that. Now, is this a vintage or is this a brand new one made by somebody? I don't know. They don't really say here, do they? Okay, but anyway, if it's $30 here, then Canada would be $50. And then you got to add a little bit for, you know, mailing the tube around. So you might pay $75 to get one of these guys. That's what I would say. $75. The rest of these tubes are not terribly valuable. They're probably in the, you know, get them for 15 or $20 or something like that. I certainly got a lot of them. Well, I don't know what to do next at this point, other than to say, hey, that's it for today. I'm going outside where the sun is shining. Yes, the sun is shining, and I got lots of work to do outside. Thanks a lot for watching, and we'll just plug along further with this, and maybe somebody will send me an email with a link to the schematic for this thing. Maybe. Is that you? You going to do that? Thanks a lot for watching, and I'll see you on the next video as soon as I get my mouse working here so I can sign off. Oh my gosh, what is going on? Maybe the batteries are weak in my mouse. Bye. Bye. Goodbye.